Hello, this is Dr. Hassan with Innovate, and this is lecture number 57, Derivation of State Graphs with the application Design of Taillight Controller of Chapter 9, Design of Synchronous Sequential Networks for the course Digital Logic Design for Digital Systems or Digital Electronics. This is a disclaimer for you to read. I cite 3 references in digital logic design, however, there are many books in the area. In chapter 9, we talked about the derivation of state graphs. Then we started with a number of applications to show you that finite state machines is an excellent alternative and a cheap alternative for many applications that could be done otherwise with microcomputer systems using a microprocessor chip, microcontroller chip. We can replace all this with a very cheap approach to design many applications with finite state machines. Then we'll talk about, once we finish the practical applications, we'll talk about reduction of state tables. Then we will talk about finding the best state assignment to reduce the amount of hardware needed. Then we'll talk about implementations and implementation approaches. Then we will also cover VHDL design 8 to design finite state machines. What's the design problem here? The design problem is to derive the state graph for the 3 input, 6 output Morse sequential network used to control the tail lights of a Ford Thunderbird. There are 3 lights on each side of the vehicle, on the left side and the right side. They operate in sequence to show the turning direction, as shown in the picture here. When we have the left turn pattern, we start with light left 1, then 2 lights will be on, then 3 lights will be on, then the cycle goes on, 1 light, 2 lights, 3 lights, then we continue doing that. And if we request a right pattern, or R will be 1, all the right turn pattern will be on. We start with right 1, then right 1 and right 2, then lights right 1, right 2, and right 3 will be on. Then we start again with R1 on, light R1 and R2 on, then R1, R2 on, and again, and so on. You go cycle and cycle until the right signal, the right input signal is removed. When the hazard input signal actually is requested, all the 6 lights will flash continuously. So all the outputs will be activated and will flash at specific frequency, and the frequency is chosen by the free running clock that we design to activate the network. The solution for this simple problem is as follows. The inputs to the network are left, right, and hazard, or simply LRH, and the output consists of 6 control signals with 3 lights on the left side and 3 lights on the right side, namely L3, L2, L1, R1, R2, and R3. So starting with a reset state as 0, all the lights are off. It means L2, L3, L1, R1, R2, R3 be 0, 0, 0, 0, 0, 0. If the left turn is requested, or it is 1, the right and the hazard are zeros. In other words, the inputs LRH to the network is 1, 0, 0. The left pattern is activated in 3 states. S1, where left 1 will be on, and the outputs will be 0, 0, 1, 0, 0, 0, followed by S2, as long as the left request is still active. So then we go to S2, where the output will be L3, L2, L1, R1, R2, R3, which is 0, 1, 1, 0, 0, 0, and then followed by S3, with the output L3 will be on, and L2 will be on, and L1 will be on. So the outputs will be 1, 1, 1, 0, 0, 0, the left turn will repeat itself as the input set LRH will be 100, and if H continues to be 0, if H continues to be 0, the cycle will repeat itself because we will go to the reset state as long as the left request still 1, so we continue with the cycle over and over and over again by activating 1 light, then 2 lights, then 3 left lights. Similarly, when we request right turn. So if we request a right turn, so R will be 1, the left will be equal to the hazard will be 0, all RRH will be 0, 1, 0, and the pattern again continue just on the right side of the vehicle. So we start with light 1 will be on at the state S5, S4. Then right 1 and right 2 will be on at state S5, and right 1, right 2, and right 3 will be on at state S6. And we continue as long as the hazard is 0. We repeat the cycle over and over and over again, and the right turn pattern will repeat itself as long as LRH is 0, 1, 0. But once H is 1, okay, we will go to the hazard state. So let's look at the design, how it will look like. So in all cases, if the hazard 1, regardless of the value of L or R, which is they are don't care, we go to the hazard state as 7, where all the lights will flash at a desired flashing rate, which is organized by the clock, or selected by the clock that we designed. So L3, L2, L1, L1, L2, L3 will be 1, 1, 1, 1, 1, 1. And we exit from a 7 at any change, okay, that occur at the inputs, whether it is the hazard change to 0 or actually change in the left turn or the right turn. So we go to a 0 once LRH will be dash 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 or don't care, so we will reset the network. So again here, initially we are in a 0 in the reset state and the inputs of zeros. Also all the output will be 0 and no light will be active. Once we start the left light pattern is 1, 0, 0, we go to S1 and light left 1 will be on. Then we are continuing to be the input 1, 0, 0. It means the lever of the left hand is still on. Okay, so we activate light left 2 and 1, then left 1, 2, and 3 with S3. Then if the hazard is still 0, we go to S0, and if the left is still 1, we go through the cycle again, and this is what we see the sequence. 1 light, 2 light, 3 light, 1 light, 2 light, 3 light will repeat itself cycle after cycle until either we go to hazard by activating H to 1 or removing actually the left turn. Okay, so if it is 0, we go to a 0 accordingly. So we go to 0 accordingly. Once we remove the left turn, okay, so we go to 0 accordingly. Now the same thing with the right pattern, similarly on the right side. So if the right signal is on, or we have 0, 1, 0, 0, 1, 0, 0, 1, 0, the light will be light 1, then light 1 and 2, then light 1, 2, and 3. And once we have actually at a 6, hazard still 0, we go to a 0, and the cycle will repeat itself to give me the beautiful pattern of 1 light, 2 lights, and 3 lights on continuously until the right turn is removed. So once the right turn is removed, we go definitely to S0. We go to S0. Now, if the hazard in any state, if the hazard is 1, we go to a 7, and all the lights will flash continuously until the hazard is removed, and we reset the machine again to a 0. So this would be the complete design of Taillight controller. It's super simple, very easy, very enjoyable, and would be very nice if you build this machine and you build it. You have only 8 states, so you can build it with 3 flip-flops. So if you complete the design of this machine and you build it and you test it, it would be quite enjoyable. This is the end of this lecture. I thank you very much for listening. Please subscribe and give me a thumb up. To subscribe, click on the blue circle. Hopefully to see you very soon in the next lecture. Sincerely, Dr. Hassan.